Decorator Pattern is a structural design pattern that allows behavior to be added to individual objects dynamically, enhancing functionality without altering the object's structure. And it's used to extend or modify the behavior of objects by wrapping them with additional functionality through composition. So say that we have an application that allows users to store data in the cloud. The data can be sent to the cloud as it is without any processing, or it can be compressed and or encrypted before it's saved to the cloud. So here's a UML diagram for a basic sort of almost naive solution to this problem. So here we have our cloud data class with a URL for the location where this data is going to be stored in the cloud. We have a constructor where we pass and set the URL, and we have a save method where we pass the data that we want to save to this URL location in the cloud. We then have some extra classes that extend this cloud data class and add some extra functionality. So we have an encryption class which also has a save data method, and here we are overriding the method in cloud data and adding some extra functionality to encrypt the data before it is saved. We also have a compression class which compresses the data before it's saved, and then we have an encryption and compression class which both encrypts and compresses the data before it's saved to the cloud. So far everything looks okay, but then the boss says that we need to create a new validation class to validate and clean the data before it's sent to the cloud. And we can see below that our code starts to look bloated as we need to make lots of new classes just to add one extra feature. So you can see here our sort of class library is becoming very, very quickly bloated. So to add one new feature, this new validation feature, we have to create 4 new classes, and our class library is actually growing here exponentially. So this is not good, maintainable, or flexible. So let's see what this looks like in code. So first of all, let's create our base cloud data class. And this cloud data class needs to have a URL field. And we're making this a protected field so that the classes that inherit cloud data will have access to this URL field. If we made it private, then it wouldn't be accessible to all of this class's subclasses. So next up, we will create a constructor where we can pass the URL location of where we want to store the data in the cloud. So finally, we need to create a save method, and we're going to make this a virtual method so that it can be overridden in subclasses. And we're just going to make the data some sort of string to keep things simple for now. And we're going to log saving data to cloud at the URL location. Okay, so that all looks okay. So now we're going to create our compressed data class. And this needs to extend the cloud data class because we're adding some extra functionality. And here we can generate the constructor for cloud data. So we pass the URL location, and we can then override the save method inside of this class. Okay, so what we want to do, here we are, let's remove this for now. So what we want to do is first compress the data. So I'm going to say for compressed equals compress, and then I'm going to pass the data to this method. So let's create this compressed, let's call this compress, and let's create a method called compress. and we can pass the data. And what we're going to do is we're just going to trim or sort of create a substring from the data. So we're going to return data.substring, and then we're going to go from the first character up to the 9th character in the well, this will be the 8th character, so from index 0 to index 9 in the string. Okay, so we're just trimming the string down basically. And this is our way of sort of pretending or simulating compressing the data. So next up, let's create our encrypted data class, which will encrypt the data before it is sent to the cloud. And again, we need to inherit from cloud data, and we need to generate the constructor for the cloud data. And again, we're going to override the save class. And again, we're going to call base.save. So base is going to be the base class, which is cloud data, and we're calling the save method on cloud data and passing the data. But what we need to do is pass some encrypted data. So we can say var encrypted equals encrypt, and we're going to pass the data. So then we can pass this encrypted data to our save method. So let's actually create this encrypt method now. So this is going to be a public method that returns a string. It's called encrypt. It takes some string data, and we're just going to return some random strings. So we're going to pretend to encrypt the data. Okay, so this is like simulating encrypting the data basically. Okay, and we're going to pass that to our cloud data save. So here we encrypt the data, then we save it. Okay, so essentially we've added some functionality to this cloud data class by extending it. Okay, so finally let's create our compressed and encrypted data class. So let's create that. So we're going to say compressed and encrypted data, and again we extend cloud data, generate the constructor, and we're going to override the save method. Okay, so in here what we want to do is we want to get the compressed data, and we want to pass the URL which we have inherited from cloud data, and we want to call compress, and we need to pass the data to this method. So now we have the compressed data. Let's now encrypt this compressed data. So we can say encrypted and compressed equals new encrypt data, and we pass the URL, and then we can call encrypt and pass the data. And then we can pass this encrypted and compressed data to our base cloud data save method, so that we store it to the cloud. Okay, so this is everything that we need. So let's now go ahead in our program.cs file and use this solution. So I'm just going to copy and paste a few things in here to save some time. So here we have a URL for the location to store the data. So I've just put Google Cloud for now. We have our data that we want to save, and we have a boolean here that says compress equals true, and we have encrypt equals true. So here we want to store some data to this URL location in the cloud, and we also want to compress and encrypt the data. And this can essentially sort of simulate some sort of user input data. Okay, so the user might specify the location and the data they want to save, and whether they want to compress and encrypt the data before saving it. So now that we have the user this input data, we have to select the correct cloud storage object. So first of all, we can create our cloud data object. And we pass the URL. And then what we can do is we can add some conditionals to check whether we should compress and or encrypt the data. So we can say if compress and encrypt, then we can reassign cloud data to a compressed and encrypted data object. So we can say new compressed and encrypted data, and we can pass the URL. And then we can say else if compress, then we want to set cloud data equal to compressed data, and we pass the URL. Okay, and finally we want to check if we are just encrypting the data, and then we can say cloud data equals encrypted data and pass the URL. And that should be new encrypted data. Okay, so as you can see in the client, we have to check whether we should compress and encrypt, or just compress or just encrypt, and then we set the cloud data object equal to the appropriate class type. So finally, now that we know that we have the correct way of storing the data, we can simply just call cloud data.save, and then we pass the data to this method. So let's run this. Okay, so this seems to be working correctly. The data is being compressed and encrypted because these are both true. So as we discussed, our total number of classes is going to increase exponentially with this solution. But another issue is that we have to perform lots of conditional checks in the client whenever we use this solution. So for example, if we add a validated data class, then we'd have to add conditionals for encrypt and compress and validate, and also compress and validate, encrypt and validate, and also just validate by itself. So we'd have to have 4 extra conditional statements just to add one new feature, and this is really not good. And this is actually going to continue to get worse and worse exponentially as we add more classes or features. So this is a really bad solution. So let's now use a design pattern to solve this mess. So the solution to this is to move away from inheritance and use composition instead. So you may have noticed by this point that a lot of design patterns are based on moving away from inheritance and towards composition. So with composition, one object has reference to another object and delegates that object some work. And this allows you to use polymorphism and switch between objects at runtime, making your code more flexible. Whereas with inheritance, the object itself is able to do that work, inheriting the behavior from its superclass. So with inheritance, we have to create lots of new classes. With composition, we can wrap or decorate existing objects to add new functionality. So here we have the UML for the Decorator Pattern solution. So we can see here we have a data interface with a save method that accepts the data. We then have our cloud data class, which has, as before, the URL location for storing the data in the cloud. And we pass this via the constructor, and it has a save method which we have to implement from this data interface. We then have a data decorator class, and this also implements the data interface. And you can see here that we have a wrappee field, and the wrappee is essentially the object that is going to be wrapped. And in our case, that's going to be our cloud data object, because we're essentially, what we want to do is add additional functionality, or at least have the option to add additional functionality to this cloud data class. So we want to be able to add the ability to encrypt or compress, or both compress and encrypt. So here we can essentially wrap this cloud data object in a encryption decorator or a compression decorator. So you can see here we can pass the wrappee into the constructor, and we also have our save method because we are implementing this data interface. And then we have our sort of specific decorators. So this data decorator class is kind of like a little bit of a helper class that contains some sort of common logic for what decorators should be able to do. So if I just read this paragraph here, so above in this UML, we are making the encryption and compression objects decorators because they are decorating the cloud data object with some additional behavior. Because decorator classes have some common logic, for example, referencing a data source object, we have created a data decorator class where this logic can be inherited to prevent code repetition. So this means that encryption decorator and compression decorator will share some common fields and logic. And for example, in our case, both of these classes need to wrap the cloud data object, and this should probably be referencing a cloud data object. So essentially, our decorator classes are composed of, or are decorating or wrapping, a cloud data object, or any object that implements the data interface to add extra functionality. So let's take a look at the Gang of 4 UML for the decorator pattern. And as you can see, it's basically the same as what we have in our solution. The only difference being the names of the classes. So if this isn't making much sense, then don't worry, because things will become a lot clearer as we code out this solution. So now we're going to implement our solution using the decorator pattern. So first up, let's create the data interface. And this needs to have a single method for saving the data. Okay, so next let's create our cloud data class, and this is going to be the class that we are going to wrap or add functionality to. In other words, decorate. So we're going to decorate this class with additional functionality. But first of all, let's actually create this cloud data class, and this needs to implement the data interface. So let's implement the interface. And in here, again, just as before, we need to store reference to the URL that we want to save to. So I'm actually just going to copy and paste what we had beforehand because it's exactly the same. So you can see here that we have a URL location for storing the data. We pass that via the constructor. Then we have a save method for actually saving the data. So this is exactly the same as what we had before. The only difference is that we are now implementing this data interface. So now let's create our data decorator abstract class. And again, this needs to implement the data interface. Okay, so this needs to store reference to some sort of data object. So this is going to be the wrappee object, or the object that we are decorating or adding functionality to. So let's create a protected field of type data. And the reason it's protected is because the encryption decorator and the compression decorator need to have access to this data field. So that's why we are making it protected and not private. So next up, let's create the constructor so that we can pass a data object to wrap. And then we can set the data object in the constructor. And then we have our save method. So we actually don't want to implement this method inside of the data decorator class itself. We want to make this method abstract so that it can be overridden or implemented in the compression and encryption subclasses. So we can make this an abstract method, and then we need to make this class abstract, and that is everything we need to do inside of this data decorator class. So now we can go ahead and create our compression decorator. And this needs to extend data decorator. We then need to generate the, we need to implement the class and also generate the constructor. So we're passing the wrappy object again to this base data decorator class, and we're also overriding this abstract save method from data decorator. So this is where we're going to add our compression logic. So this is going to actually be the same as what we had beforehand in our compressed data class. So we can copy and paste the save and compress methods from what we had before, and that is all okay. We just have an issue here because we actually need to say base.data. So we're now using composition here, so we call base.data to get the data field, and then we call the save method on that data field, and we can pass the compressed data. Okay, so that's all we need to do there. So I'm also just going to log whenever we call the save method so that it's easy to see what's going on. So I'm just going to put compressing data. Okay, so I think that's everything we need in our compression decorator class. So let's now go ahead and create our encryption decorator. And this needs to extend the data decorator. And let's now implement the abstract class and also generate the constructor. So you can see here that this data decorator is just a kind of class that makes it easier to create the different decorators. It's just basically a kind of helper class where we have some basic setup for a decorator, which is essentially just passing some sort of wrappy object into the class. And it saves us from having to write this logic inside of both of these classes. We don't have to bother recreating this. Okay, so it's just preventing a little bit of repetition basically. So here we have our encryption decorator, we have our constructor. So now we can implement the logic for encrypting and saving some data. So let's copy what we had before because it's not going to be any different in terms of the logic. So let's copy and paste those methods, and again, instead of calling base.save, what we need to do is call base.data.save, and then we pass the encrypted data. Okay, so that is everything we need to do. So now let's actually use this solution in the client. So what I'm going to do is I think I'm going to remove all of this, and I think I'll also remove this, and let's re-import these objects. Okay, so first of all let's create our cloud data object. So this is going to be called cloud data, and it's going to be equal to new cloud data. And then here we need to pass the URL that we are saving to. Okay, so next up we can add our conditional statements. So we can say if encrypt, if encrypt is true, so if the user wants to encrypt the data before saving, then we can reset cloud data equal to new encryption decorator. So let me show you, actually, this is going to be easier to just show you. So cloud data equals new encryption decorator. So we create a new decorator and we pass the cloud data to this class. Okay, so you can see here that we are wrapping or decorating the cloud data with an encryption decorator. Okay, so we're adding some additional functionality by wrapping this object inside of a decorator. Okay, rather than creating a new specific subclass. Okay, we're wrapping using composition instead of using inheritance and creating a new encryption data class like we were before. And now what we can do is we can say if we want to compress, so if we want to also compress or just compress alone, we can wrap this cloud data inside of a compression decorator. Okay, so that's all we actually need to do. Those are the only conditionals that we need. We only need to add one extra conditional for every type of feature that we have. So then at the end, we can call clouddata.save, and then we can pass the data, and then let's run this program, and we can see that we are compressing the data and then saving data to the cloud at google.com. So we are compressing and encrypting the data. If we make compress false, let's see what happens. We can see that we are just encrypting the data. If we make both of these false, let's see what we get. We just save the data as it is, and everything seems to be working as it should be. Okay, so this is perfect because now if we, for example, want to add a new feature, say a validation step, then we just have to add one more conditional. We just have to say if validation equals is true, then we can wrap in a validation decorator. We don't have to create a load of new subclasses. We just create one new decorator class, a validation decorator, and we just have to add one new conditional to the client. We don't have to create a validation plus compression, a validation plus encryption, a validation plus compression plus encryption subclass. We don't have to create all those subclasses and then add conditionals for all of those new combinations of steps. So this is a much more maintainable solution using the decorator pattern.